All right. So, Raymond, thank you for joining us. I'll just do a quick intro, then we'll go over to you to do a screen share. So, look, we're super pumped to have you here. I know Adobe's been doing so much great work in 3D for many years, and it's great to see the work that you're doing in Gaussian Splat. So thank you for joining us to share that. And then Raymond's also been very active in the SIGGRAPH conference, which we very much appreciate the work that you do there to help bring the community together. So, over to you.
Hello everyone. I'm Raymond. I'm working as a senior research engineer in Adobe. My daily work is transferring new researchy technologies into Adobe 3D products. In particular, I worked a lot on Gaussian splats, formatting, and rendering here. Today, my presentation's topic is Gaussian splatting in Adobe Substance 3D Viewer. So what is Substance 3D Viewer? It's a new app we shipped last year to help you to more easily view and explore 3D. It can open multiple 3D model formats, contains a powerful render to help you to create images from 3D model and even generate images from 3D. It's a free app so that it's in beta phase. So if you have the Creative Cloud app installed, you can open the app looking for beta tab and the 3D viewer should be there and it can be installed from there. Uh, here, if you check beta and you find the Substance 3D viewer beta. So it's both a Photoshop plugin and a standalone app. You may open the 3D model in the app, but if you have both the app and the Photoshop beta installed, you can also drag and drop the model directly into Photoshop as a smart object. Here's a demo. And then you can edit the content to view and rotate the 3D object and then export back to Photoshop. This viewer supports about 70 types of 3D file format, including meshes, materials, point clouds, and in particular, Gaussian splats. It contains both a raster and a modern GPU path tracer. Also supports texture 3D or image generation. It's light but powerful. Today, I want to focus on is about Gaussian splat, which I believe is also a topic our audience here are interested about. Uh, so, okay. So what is a Gaussian splat? The Gaussian splat is a 3D format made with points, but each point has a special properties. Like here, I show this armor is a Gaussian splat. It has photorealistic appearance, meaning it records light and material faithfully. There's no 3D complexity, which means you don't need to consider materials, lights, UV, or topology, or anything that's considered very daunting for non-3D people, which it makes it very friendly for who has less 3D experience. It's also very easy to build from images or video. For example, the Gaussian splat on the left is reconstructed from this video I just showed here. And everything can be reconstructed in minutes. That's faithfully records everything, including light, material, and extra. So it's also efficient to render like 200 frames per second in real time, enabling rich editing and generation. Yeah. So besides, this format is also fully differentiable, making it naturally integrated with large generative AI models. I'll show examples about why this is crucial for us. Okay. So why does Gaussian splat matter to us? It has nice properties, but more importantly, we need to have some business use case to push this further. We explored this a lot in Adobe. We've found several workflows that could be very useful to our customers, and these workflows can be only enabled by the power of Gaussian splatting. The first workflow is trivial. So imagine you want to advertise a sneaker made by your company. Now, without a hand-made a CAD model or CAD model, you can simply scan it as a Gaussian splat and directly put it into Photoshop. You can rotate camera and shadow to whatever looks you like, and then you compositing it with your poster. Here, one benefit of the Gaussian splat is that the renderer will faithfully reproduce whatever you see in the real world. You don't need to worry about materials or geometry complexities or all the UVs or the 3D jargons. You can just put it there. And the 3D assets is just look like whatever it should be in the real life. That's one benefit of the Gaussian splat. Another workflow we explored is to use Gaussian Splat for concept design. So imagine you're still a sneaker designer. You may want a new design for the next year with different colors, but also with some flavors similar to the old one. So here in the Substance Viewer, you can scan a current sneaker as Gaussian Splat without the need of a CAD model again. Just scan it and you load it here and renovate this new design with new colors using text prompt. For example, like here, I'm just trying different text prompt for this design. It will remain some flavor of the old design, but with assign a new color to it. And they're all under the same camera perspective to help you to compare between them. So this is power of combining Gaussian splat with a generative model that help you to conceptualization of new stuffs. So we can even push this further to use generative Gaussian splat to guide image generation. Here's another workflow, which helps you to make a storyboard in minutes. It could be a storyboard for advertisement or show some lifestyle you want. For example, here I use generative G-Splat, make a storyboard for a Shiba Inu's daily life in the evening. The generated Shiba Inu is a Gaussian Splat. This is Gaussian Splat. And it may have some poses I want. I can place it at where I think the shot should look good. Then I use this another generated model, which is a 3D to image model to produce the cut by adding some details like you see here. And remind that G-Splat or Gaussian Splat is format that can be naturally integrated into a large generated model. And this is crucial because you can generate a 3D model, a 3D Gaussian splat in seconds instead of minutes. So it is much quicker than generating a mesh. This will help you to rapidly iterate between different variants. So here I'm just using this 3D model image to recolor it or using the AI render to make it a refined shot. And here's the final result where we have this forecast of this cute storyboard about this Shiba Inu. Okay, so the next topic I want to discuss is what we did to make Gaussian splat more easily used. A large portion of the power of Substance 3D Viewer comes from the effort we made it to be USD native, meaning that everything there is under the powerful OpenUSD framework. The benefit of OpenUSD includes interoperability, where it's a common language and file format, allowing users to exchange 3D data between different production tools. Its layered data system also allows users to edit without destroying the origin data, helping you to better collaborate and manage assets from different sources. And based on this, we developed a USD file format plugin that can convert many different types of assets into USD, including Gaussian splat, whose de facto standard format now is PLY. But then we can convert it using this plugin into USD when you import or export a Gaussian splat into or from the viewer. And using USD, making a Gaussian splat integrable with other common used format in 3D production is simple. Like we can combine this with meshes, lights, or camera stored or produced from different sources from traditional 3D software. So everything can be integrated easily with OpenUSD. And for example, here I have this playroom as a Gaussian splat captured with a phone. And then I can compose meshes into it. For example, this baby crib is made with meshes, and everything is combined in 3D. So imagine you're a designer for a company making baby cribs, and you want to know how your design looks in real world. You don't need to produce it in real world, but you can just scan and reconstruct the environment you like as a Gaussian splat and put your design, your 3D model into it. And this is only possible with the plugin's ability to compose assets from different sources. And by the way, if you zoom the camera into this crumble on this baby mobile, you would see the reflections of Gaussian splat playroom at the correct distance, and translucency with physically plausible refractions plus the correct camera defocus blur. This is only possible with the production level ray tracer in Substance 3D Viewer. And with such a ray tracer, the Gaussian splat is better at lighting than a simple environment map. So that's also the powered by the captured Gaussian splat. So let's dive into some more details. Here's a PLY header for the Gaussian splat, and I'll show you how we map a Gaussian splat PLY into the USD format. We map a Gaussian splat into USD point geometry because the G-splat is essentially a point cloud with special attributes. So we map the splat position into the USD geom points attributes. And we convert the diffuse spherical harmonics to points display color, which is just the color for points in USD. We also convert the opacity into points display opacity, which is usually used for translucent point, but it's fine here because G-splat is just a kind of special transparent points. And there are three scales in Gaussian splat. So we map them to the point's width. And finally, record other attributes like rotations or high order spherical harmonics as the primors in the similar name used by the PLY. So we have open sourced our PLY USD converter in our USD file format plugin. If you go to our GitHub repo, I have a link here, or you can scan this QR code there. You would find the Gaussian splat converter living in this PLY folder, which contains the USD PLY plugin for exporting and importing of Gaussian splat from and to USD. We hope this repo would help you to use Gaussian Splat as the building block of your production tool because we believe such tools will help people in the world to better enjoy 3D, to better democratize the power of 3D. And there are some related topics to be discussed about this file format plugin. We currently support standard GSplat, but it's still an evolving format as know that there could be new papers, new research works coming out in weeks. For example, there could be a Gaussian splat with better reliability or better specular diffuse separation in future. I did hear some voices suggesting this could be too early to standardize, but I think there's still a path where we can build some consensus over the commonly used features. So this is partly the reason we open source the USD PLY plugin. We only support PLY for now. Another commonly used format is particularly on the web is the GLTF. I know there are already some effort on the GLTF GSplat schema, but one thing I think would help on this is to share more business use case where Gaussian splat needs to be composed with other kind of assets. So we could have a bigger push across the industry if there are more use cases to show that GLTF is valuable for the business. Also, We're exploring different solutions for compression and streaming. For example, the recent SPZ format looks pretty promising for compression. And for streaming, there could be some solutions for quickly previewing a Gaussian splat asset. So yeah, thank you. If there's any questions and concerns, comments, that will be welcome. Thank you.
Fantastic presentation, and I mean, just really nice work showing those use cases and those visuals from the product. And then I love the discussion and perspective there around open standards. So let's open it up for questions. Who has the first one?
Um, I have a question. Uh, Thank you very much. That was a lot of amazing information that I'm still digesting. I My question might be a little basic or not. It's basically I'm curious about the entire concept of um, normalizing the lighting. Say when you're taking a scan for a Gaussian splat and bringing it into the software, and then you've done the scan in a certain lighting scenario. You can, of course, apply your own generative materials on that, but maybe you also want to normalize the look of the scan so that it can be adaptable to any lighting environment that you put it in, or vice versa, how the lighting is being extracted from the Gaussian splat to be applied on meshes put in a splat environment.
Oh, I see your question. So you're asking whether we need to normalize the brightness in layman's word of the Gaussian splat.
Mhm.
So currently, we just provide like you can make it brighter or less by just multiplying a scalar to it, so user can freely adjust how bright the Gaussian splat look like, and because we're using a path tracer, we can just trace the path, trace the rays, and grab the lights from the environment. So we don't use idea of normalization because it's just a you can treat it as a complex point light source and just use it as whatever the user wants it to be. So we don't normalize. Say there's no reference saying this is the brightness it should be.
Thank you.
Other questions?
I've got a layperson question. First of all, great presentation, Raymond. Thank you so much for coming today.
Thank you.
The natural language that you used with the sneakers and the dog, how involved and intense was that? Where's that dictionary or library live? Who creates that? How is that ongoing? That I found really fascinating. And I'm the non-software developer here, but how did that come about? And
Sorry, I may misunderstand. What's the question? Like you're asking where is there a software library to generate the dog or something like that?
and how is that maintained? It just seems vast to be able to use just the way that people naturally speak of show me a white, whatever kind of dog that was that you were showing with the background sitting at a window. Like there must be a huge library.
Oh,
Maybe it's not
I
a good
see.
question.
You're asking where the generative part come from. So that part come from Adobe Firefly. So it's Adobe's product for generating using text to it could be a text to image, text to 3D, and we're recently on the news for the text to video. So it's part of the Adobe Firefly.
Thank you.
Other topics, comments, questions for Raymond? So maybe one from me. You mentioned, starting to take a look at compression, and then the SPZ open source format from Niantic. Have you taken a close look at that? Do you have any thoughts on it yet?
So what I can say is that we are exploring on it, and we find it's promising because on our test sets, it shows like 9 to 10 times compression. It has some like quality loss on the high order spherical harmonics if the set is very specular, but for Euro assets, there's no discernible difference in height by just looking at it. So we think this is very promising, but we're still exploring.
Wow. Yeah. So maybe for many use cases for the non-expert and non-extreme specular, the compression may almost be unnoticeable. Is that right?
Yeah.
That's cool.
Yeah, and we also wonder what's Niantic's next step for expanding or whatever on this SPZ format. Yeah.
Come to the town hall in 2 weeks. They'll be presenting. So yeah, cool. Other questions?
I have one question. Sorry, please go ahead.
That's right. If I take a Gaussian splat from one environment and let's say a couple of objects, which I also create some Gaussian splats from a different environment, and the lighting, let's say, was very different in them, and now I want to go and combine them. What happens? Does it just magically work, or I guess I'm wondering about composing Gaussian splats from different sources.
Yeah, I think that's one current limitation for Gaussian splat is that the light is just whatever it is recorded or at the time it's reconstructed. But we believe in the future there could be new research work on adapting or relighting a Gaussian splat to another light environment. And actually, we have already seen multiple works coming out from like on Archive. There are new works about relightable Gaussian splatting, but I think it's still a topic. It's an open question for the researchers.
Cool.
Arjun, did you?
Raymond, maybe. Yeah. Sorry, lost.
I had a similar question, basically, about compositing, whether one can composite multiple Gaussian splats within Substance Viewer.
Mm-hmm.
And then I'm imagining that perhaps a composited large Gaussian splat environment would be good in a OpenUSD scene eventually. But whether that compositing and that stitching work can be done in the Adobe tools.
Yeah. So currently, in the viewer we have shipped, we are only supporting import one object for now. But yeah, in the future we're still exploring whether we can like use that as a tool for stitching multiple Gaussian splats. Yeah.
Or Nick, do you want to add anything to your comment here about the combining splats in the chat?
I'm only echoing what was just said, that it's open research.
Cool.
Yeah.
And
I guess continue the question of compositing, then I guess I'd heard that there's also some work going on. I mean, I have no clue where, in terms of trying to get the lighting from Gaussian splats to play better with physically based rendering models. And I would imagine if you have several splats and you can magically get out some PBRs, that those could be composited. But
Yeah, I think one problem is that we need better normal. I know there are already multiple work on that. We need normals to be extracted from the splats. So if you have splats that looks good, but the normal are in random direction, it will be very difficult to get a PBR model from it. So we need consistent normals. There's already works like called 2D Gaussian splat in Lester Seagraph for aligning normals, and there are following works on that. So once we have accurate normal for the object, then we can say we can extract like diffuse or specular component from that. I've already seen some research work on that to not just record a final radiance, but instead record like reconstruct the diffuse or specular components from that, and then use a PBR material model to light it. So that's another direction to explore. But those are very researchy work.
One cool thing that you can do today is if you use Gaussian splat of an environment and assume a radius of the splats, you can extract a lighting environment from splats directly. And if you have a way to remap the splats to a luminance value, like and normalize those things, you can use a splat environment for lighting a PBR model, which is a really cool aspect, but it doesn't go the other way. But capturing lights is a really valuable workflow today.
Yeah. So basically, in our path ray tracer, we treat Gaussian splat as a special kind of point light. Like each splat is a point light with a like elliptic shape, and then we can use that to relight the meshes we put into the scene. Yeah.
In your talk with that, you had like a reflective ball in the middle, and then there was a background that was a splat. What was that an example of that?
Yeah. That's the one I'm talking about.
Cool. Good discussion on lighting. Other comments, questions? So Raymond, I have a question. I think that you're uniquely positioned to have an interesting perspective on. So one is, you're doing, I guess, kind of technology transfer from research into product. And when I look at the history of graphics as a whole, I think the field is quite impressive in terms of the amount of research that quickly got to product, right? And you look just at what Pixar and NVIDIA has done. And then I look at the pace of recent research in Gaussian splats, and then all these folks, in industry, right, shipping product. So what's your perspective? Do you think, is this like among the fastest that we as a field have moved with respect to research to productization?
Yeah, thank you. That's a good question, I think. I think, yeah, I think this is a good point that we just try this new format and other new workflows enabled by Gaussian Splat, like what I presented in my talk, that it indeed enables some new workflow that's not possible in before, and in particular, it's democratized the use of 3D. Like traditionally, you need to worry about materials, UVs, and all the complexities in 3D, but with this new tech, new research works, we see the trend. I think it's just also beyond Gaussian splat. It's just a trend that there will be tools that more and more easily for like non-3D pros to access or to create with 3D. And actually, there are a lot of people really interested in it, but they are not enabled before because 3D is too complicated to them. And I think it's a good point where we can use all these new tools to create a better environment for these people, and so that we can expand how computer graphics or 3D is applied to the world. Yeah.
Cool. Other questions?
I have
Raymond,
one
were you
question.
expecting? Oh, please go ahead.
Um, So it's about then also bringing back everything coming from these new pipelines that based on through Gaussian splatting into interactive 3D environments and interactive 3D applications. Say, for example, bringing something that we've made in Substance Viewer and maybe USDC, and then bringing it into a game engine, and then people making games or interactable virtual world applications with it. So, which is kind of where the 3D Pro and their complex knowledge base also still lies. Um, so I don't know exactly what that question is. It's basically surrounding the integration of what comes out of these pipelines. How well does that integrate into these interactive scenarios and workflows?
Sorry, I didn't get the question. What's the question?
So basically, say I'm working on a game,
Uh-huh.
and at the end of the day, I'm going to be coding some interaction in that game, and I'm going to be making game assets using these 3D Gaussian splatting based pipelines. And so, and there one is quite used to the whole 3D mesh PBR setup. So how can the work in this field contribute to bringing these assets back into those kinds of applications?
I think there's still a path because Gaussian splats records everything as radians for now. And one thing we can do is just like if you have any PBR sets, you can just say render them around and then convert them into a Gaussian splat, and then you can share with people who don't care about the lighting or how those material are set up, and then they can just directly put Gaussian splat into the environment they like and to compose or to have some other applications. Does that answer the question or?
So better as static objects in an environment rather than an interactive object.
Yeah, I think it's more like a thing we usually call baking in the old times. Like you can just bake everything into a Gaussian splat, and you can share the baked object with lighting materials and to people who don't care about those.
Raymond, if you don't mind, I'll throw one more from me. So, I thought you had a very pragmatic perspective around the open standard, saying, hey, there's innovation and there's research, but perhaps there is a subset that we could build consensus around. If you were to take a no pressure and no obligation, just kind of, first pass on where you think there is consensus that we would start, unifying the ecosystem while still allowing, that longer term innovation, what do you think it is?
Well, I think starting from the format of the most basic Gaussian splats would work, as we can see that there are already different practical business use case coming from different companies. So, and they're all built around the current Gaussian splat format. There, meaning there's no need to add like PBR or other things, more complicated stuff. So I think there's already a common point that people can use in their actual work if we have like a standardized format for GLTF or USD or whatever the common format there is. Yeah.
Cool. Folks, other questions, comments? So Remy, I've loved this, and that this is like exactly how we want these education sessions to go, and that the Q&A was as long as the presentation, right? Which is perfect. Was there topics or questions you thought were going to come up that we haven't raised that you want to talk about?
Nope, I'm good. Thank you.
Okay. Last call, folks. Other questions for Raymond? Okay, so what we'll do, we'll stop the, I'm sorry, Leslie, you come off mute. Did you have a question?
Yeah, it was just maybe what are the limitations that you find with G-Splats with what you're trying to do at Adobe? What
So
it could do that it's not, or
I think one thing we really want to explore is relightability, like the ability so that people can change the light around it. Of course, this will introduce like what's the material model, what's the like the how to calculate the reflection reflection more accurately something. But yeah, I think that's some parts we really want to improve on because people use this usually not just for viewing, but a lot of time they want to add it, they want to compose it into new environment. So currently we are using the 3D to image ability, the Gen AI ability for relight a Gaussian splat, but we also wonder whether there could be more flexible ways to or more controllable ways for people to change the light. Yeah.
thank you.
Cool. Last call. Any other questions for the official part of the meeting? Okay, so Raymond, what we usually do is we stop the recording and then we have a water cooler if there's any other topics folks want to have. So if you're able to stick around, please do. But before we stop the recording, let's do another round of applause. Raymond, thank you for your presentation.